Okay, so today I'm going to explain a bit about isomers and just a bit about resonance structures, but mostly on isomers. So first, we will find the difference between isomers and resonance structures. So here we have a resonance structure, CO3. Okay, so we see the double bond here in the first image, the double bond here in the second image, and the double bond here in the third image. You can see that the double bond changes for all three images. Still, it's the same thing, nothing changes. They are all the same because of the resonance structures. It means the double bond can rotate and nothing happens. Now, what is an isomer? An isomer is it's a compound with the same number of C's, for example, but it has a different structure. It is named differently because it is not exactly the same. You can see it has a functional group to a side, yet it still has the same 4 carbon, but one's butane and the other is isobutane. And that's because of a functional group of ramificaciones, and they are not equal to each other. You have to keep that in mind. They will not be equal to, like, they have the same number of C's, but they are not equal. Now we'll explain how to identify who is. So now, first off, we have position isomers. You know that it is an isomer because they are similar, but like the double bond changes position. There's no resonance in the structure, so when you change the double bond, it changes the whole thing. It is now a different thing, and the different position of the same functional group turns it into a different molecule. It makes something else. Now, chain isomers. Chain isomers have a functional group like this one, and the main chain is not the same as the new one. So in the top one we have 4 C's in order. They're all straight in a straight line. Second, we still have 4 C's, but the main chain has just 3 C's. As we can see, it's an L shape. It just has 3 C's. So it is different because it has a different skeleton in a way. Now, functional, different positions of atoms give a different functional group. So in the top one, it's different. In the bottom one, we have cyclobutane because its functionality is different, so it's closed. And the top one, we have double. Now, geometric is different. In geometric, in this case, we have different geometry. So we have the double bond, but we have these other like atoms on the sides that we can't change. They are non-movable. The double bond also cannot move. That's what there is, and that's the only thing there is. Now finally, how to identify CSI versus trans, CIS versus trans. CIS, that first one is a trans. Trans actually means across. So you can see that the same atoms are across for each other. But on CIS, they are not across, but they are on the same side. CIS from Latin meaning on this side. So they are both on the same side. So we can see in our example here at the bottom, on the trans they are across, but on the CIS they are on the same side. And note that trans are more stable than CIS. So that's basically it on isomers, and this is a structural video.